Okay, so we're going to look at solving quadratic equations when there's no x-intercepts, and what happens in that case. So we're going to start off by looking at the quadratic equation, x squared minus 4x plus 29 equals 0, and we look at the discriminant. So the discriminant is the inside of the quadratic formula, the inside of the square root. So you get b squared minus 4ac is the discriminant. So b is minus 4, so we get minus 4 squared minus 4 times a times c. So we get 16 minus 4 times 29, and let me consult the calculator real quick. Okay, so 4 times 29 is 116. So 16 minus 116 is minus 100. Since this is negative, we're going to get complex zeros, or we also call them roots. So the solution comes from the quadratic formula. X equals minus b plus or minus b squared minus 4ac all over 2a. Well, now we already know what this is. So here's b. So minus a minus 4 is 4 plus or minus, and then we know that that's equal to minus 100. So I'm going to be taking the square root of a negative number and then times 2, or divided by 2. So I get 4 plus or minus the square root of minus 100 over 2. So I get 4 plus or minus the square root of minus 1 times the square root of 100. 4 plus or minus 10i. Square root of 100 is 10. And the square root of minus 1 is I. And then I can factor out a 2. And that's a 2 plus or minus 5i, all divided by 2. So I get 2 plus or minus 5i. And so there's my two roots. They're complex. If I look at the graph, I will not have any x-intercepts. Okay, let's look at another one. X squared equals 4x minus 7. I need to get everything on one side of the equation. So I'm going to subtract 4x from both sides and add 7 to both sides. So I'm going to look at the discriminant. So 4 squared is, or b squared is 16 minus 4 times 1 times 7. So I get 16 minus 28, which is going to be negative, but 16 minus 28 is minus 12. So my solution, applying the quadratic formula right there, is going to be minus a minus 4 plus or minus the square root of minus 12 all over 2. So 4 plus or minus the square root of minus 1, square root of 4, square root of 3 all over 2. So that's equal to 2. So I get x equals 4 plus or minus, I think that's 2 square root of 3i, and it's all divided by 2. Now I'm going to factor out a 2 on top. The 2 on top cancels the 2 on bottom, and I finally get that the solution is 2 plus or minus the square root of 3i. Complex, so if you have a polynomial with real coefficients, which is what we have, the complex roots always occur in conjugate pairs. So notice that I have 2 plus the square root of 3i and 2 minus the square root of 3i. So those are complex conjugates because the real part has the same sign, the imaginary part has opposite sign. So complex roots for polynomials with real coefficients always occur in complex conjugate pairs.